Hello and welcome to this screencast on joints. Okay, so it's Unit 2, Functional Anatomy, and this time it is the second screencast for the skeletal system, and we are specifically looking at joints and functions of the skeletal system. First of all, just go through the specification. The first screencast went through long bone anatomy, so the periosteum, bone minerals, etc. We looked at bony landmarks, location of skeletal bones, and types of bone. Now we're going to be looking at ligaments, joints, and the function of skeletal system, as well as planes of movement. Okay, so first of all, we need to be aware again, when it comes to exam prep, we're looking at the mark allocated by the question, circle the important information. Can we get the memory method from that? Can we translate it into an actual question and then extend with examples? That is how we are going to try and answer the majority of our questions. First of all, classifications of joints. Now, can you go from here? Can you name the 3 classifications of joints? If you can, pause, write them down. If you can't, can we use that to help us out? So now do we know the 3 classifications of joints? Pause it, write them down, or write them down, then pause it, however you want to do it. Okay, so we're going to go through the answer. If you haven't completed it, pause it now. We have got fixed joint, slightly movable joint, and synovial joint. Again, now that we've looked at fixed joint, slightly movable joint, and freely movable or synovial joint, can you please give me an example for each one and then give a description as to the amount of movement they allow? Give that a go from complete blank if you can. So pause now. Okay, if you're struggling with that, we can use this fill in the gaps, okay? So if you're struggling, use this fill in the gaps, pause it, give it a go. Okay, so the answers, there you go. I do not need to read through the answers. If you want to look at them, check your answers, please pause this video now. So, typical exam question. Identify the 3 types of joints found in the body. Pause this, give it a go. Answers: fixed joint, slightly movable joint, and synovial joint. Hopefully you'll be able to provide examples for each one and even be able to give a tiny bit of a description with regards to the amount of movement each of those joints allow. Okay, so now let's look at synovial joints more specifically. There are 6 synovial joints in the body. Cover up the fill in the gaps if you think you can do it from heart. If you can't, use the fill in the gaps to help you out. Pause this now and give it a go. So, answers: hinge, ball and socket, condyloid, gliding, pivot, saddle. Next to there you've got the different types, so elbow, knee and ankle for hinge, shoulder and hip for ball and socket, condyloid is a wrist, gliding, carpals, tarsals and trunk, pivot, atlas and axis in the neck, saddle equals thumb. So if we're looking at synovial joint structure, synovial joints all have these kind of landmarks or these structures. So this is what makes up a synovial joint. Can we fill in the gaps from this now? Again, you haven't got this actual document on you, so can you just list each one for me? Let's start with 1, 2, 3, 4, 5, 6. Can you give it a go? This one, slightly difficult in terms of where it is on here, but imagine that is a fluid-filled sac. Okay, so there are your answers. Bursa, that fluid-filled sac. Ligament, connects bone to bone. Synovial cavity, containing synovial fluid. Articulating cartilage. Synovial membrane. So that's a synovial fluid, all in here. Good, okay, so the ankle is an example of a synovial joint. State 2 functions of ligaments within Eve's ankle. Pause this and give that a go. Okay, you should actually know 3. We go through 3 regularly. The last exam paper was worth 3 marks. Wanted 3 pieces of information. What you could have had: attaches articulating bones, so connects bone to bones, provides stability. Finally, the other appropriate answer you could have had is prevents any unwanted movements, for example, hyperextension. Movements available at synovial joints. Can you just list all the movements available at synovial joint? Before you use this to help you out, I would put down shoulder and then go through, or ball and socket, and go through the movements available at the shoulder, then at the elbow, wrist, and so on. That may help you out a bit more. If not, use these to help you out. Pause this now. So answers are available there. So flexion, extension, abduction, adduction, internal rotation, external rotation, horizontal flexion, horizontal extension, circumduction, all available at the shoulder joint. Then we've got plantar flexion, dorsiflexion, lateral flexion, depression, elevation, pronation, supination. I have mentioned this in class, but we didn't write notes on it, and I saw that it came up on one of the exam questions, so I think it's worthwhile you guys having a go at this. So describe what is meant by pronation. Can you give that a go? So pause it now. Okay, I'll give you the answer. So the answer, the palm or hand facing downwards. Remember I said in lesson, prone is facing down, and supine is facing up. So describing pronation would be palms facing down. Describing supination would be palms facing up, similar to supine, lying face up or lying on your back. Okay, pause this, and can you provide the movements available at each one of these joints? So we've got flexion, extension, plantar flexion, dorsiflexion, lateral flexion, hyperextension, adduction or horizontal flexion I would accept, abduction of the hip, horizontal flexion, horizontal extension, internal rotation, external rotation, finally circumduction. So, what movement is taking place at the right shoulder, the right elbow and the right ankle, and what plane are the movements taking part in or place in? Pause this and give that a go. Answers: elbow joint, joint movement flexion, ankle, plantar flexion, shoulder, horizontal flexion or adduction, plane of movement, sagittal plane for flexion, sagittal plane for plantar flexion. Now, horizontal flexion takes place in the transverse plane, or adduction takes place in the frontal plane. Okay, so whichever one you choose, you need to make sure you've got the correct plane of movement there. Next one, what movement is taking place at the left hip, left knee, the trunk, from preparation to execution, and what plane are the movements working in or taking place in? Pause it, give it a go. Okay, so hopefully you've given that a go now, so I'll go through the answers. Joint, so let's go hip. So flexion's taking place. It's gone from extended to flexed. Takes place in the sagittal plane. Knee has gone from being extended to flexion. Takes place in the sagittal plane. And then the trunk has gone from facing forwards, so that is to then rotating, so rotation, and rotation takes place in the transverse plane. So nice easy exam question for you. Identify the movement occurring at Eve's ankle when she's jumping, taking off in figure 1. So what movement is taking place at the ankle joint there? Pause it, give it a go. Of course, the answer is plantar flexion. Okay, so quite a big one for you. I want you to be able to put down now for each one of these, the articulating bones for each one, and the movements available at each joint. Just put 2 movements here. This is a typo. Okay, just put 2 movements. So pause it, give it a go. Horizontal flexion, horizontal extension is a typo. Do not put them in for elbow. Why they're there, I don't know why I've done that. So, got your answers there. So, exam question, worth 4 marks, okay? Explain how movements at the hip joint allow the gymnast to achieve the position shown in the picture. So, what movements are taking place at the hip there? There are 2 movements taking place. Can we identify what they are at the hip? Pause it, give it a go. So flexion and abduction are the movements that are taking place at the hip. So they're allowing, and then all you do is they're allowing the legs to be moved upwards and outwards. Okay, so that is what they're doing. Okay. Now we are back to synovial joints. Now I need more specific information. So, what's this? Can you fill in the gaps for each one? please give those a go. Then the next one to these, so pause this and give it a go. Okay, so we're going to go through the answers now after you've paused it and filled them in. Bursa is a small fluid-filled sac providing a cushion between the tendon, muscles and bones, preventing friction. Synovial fluid, this lubricates the joint and reduces friction. And don't forget, it provides nutrients to the articular cartilage, which is found at the end of long bones. The cartilage found at the end of long bones provides shock absorption and friction. Synovial membrane, this releases synovial fluid. Then we have muscle. Ligaments, usually in a picture they're white. It's a bit annoying that this picture's pink. They're usually white because they're not very vascular, they don't have a massive blood supply, so they're usually white. Ligaments stabilise the joint, connects bone to bone, prevent any unwanted movement, e.g. hyperextension. Got the joint capsule, which supports the joint, and then finally a tendon, which connects muscle to bone. Tendon to two things, muscle to bone. So, exam question. Now, what I want you to do, the synovial joint of the shoulder allows him to complete the bowling action. Analyse how the structure of Alistair's shoulder joint allows him to complete the bowling action. This is worth 6 marks. What I need you to speak about, this is quite a difficult question, so I'm giving you kind of like a heads up of what you need to speak about. The type of joint, the movement that is taking place at the shoulder joint, the articulating bones for the shoulder joint, the function of a ligament, and the structure of a synovial joint. So that's everything that's in case with regards to this question. So pause it and give it a go. Okay, so the answer could have had all of these things. So ball and socket enables a wide range of movement when bowling. The movement that occurs is circumduction, which is flexion, extension, abduction, adduction. Don't worry if you didn't put that. If you put the movement in circumduction, that'd be fine. The humerus and scapula are the articulating bones. Ligaments connect bone to bone that offer stability. Unstable, therefore it's dislocations. Don't worry about that. If you put ligaments connect bone to bone, make the joint stable, and also prevent any unwanted or unnecessary movements would be fine. Then little things about the synovial joint. Articular cartilage found at the end of bones, used for shock absorption and reduces friction. Bursa reduces friction because it's a fluid-filled sac. Joint capsule holds the synovial fluid in place and the stable joint. Synovial membrane secretes synovial fluid. Synovial fluid keeps the joint lubricated and allows the cricketer to complete the bowling action. That there is quite a tricky question for you, where you've got absolutely everything involved with regards to synovial joint. Hopefully this has helped and you can use it with regards to revision. You don't just have to use this just for this week, you can use it again and again and again to help you out. Hopefully that has helped. Thank you very much and I'll speak to you later.